Alright, 8th grade class. So this video tutorial is basically on rate of change from a graph. What I want you to do, if you have your reference book available, if you don't, pause the video, get it out. But I want you to change to this page. If you were absent, you can go ahead and Google Miss Beatley's classroom, and you can click on student page, and you should be able to retrieve this file so you can go ahead and put that in your reference book. Alright, before we get started, let's go ahead and look at our notes that we're going to use. The couple things that we're going to use is we're going to use rate of change, and we're going to use our knowledge of coordinates. The slope formula here is going to be used for the following lesson when we start looking at rate of change from a table. So rate of change is basically defined as the rate in which a graph is increasing or decreasing. So if I had a graph going upwards, I can find my rate, which is my rise over run. How much is it consistently going to increase? If I were to make this here, you can see that my slope would constantly be the same because it's a straight line. So what I want you to do is have your book pages out, and we're going to look at page 137. It looks like this. Go ahead and pause the video if you don't have 137 out, because that's what I'm going to use as my example. Alright, let me zoom in. First and foremost, students, always read the question, because it might be asking you just a couple things or various things that you want to make sure that you include when working out the problem. We know it's rate of change, so we're going to go ahead and first read. Number 1 says Shelley reads the rate of change from the graph shown as $1 for every 2 tickets, or $1 for every 2 tickets purchased, basically. She plots a point on the graph to show the value she used to determine the rate of change. This is a straight line, so we know the rate of change is going to be the same, just as I showed you in the notes portion when I was doing the rise over run really quickly with the blue highlighter. You can see it was going to be the same. So no matter what 2 points you choose, it's going to stay. First few notes I want to kind of write is we're going to use the y-axis and then the x, because y equals my rise and x equals my run. Okay, we're going to make sure we stick with that. Now my rise is the y-axis, so I'm going to look here, and I want to understand my graph. So when I find the answer, I know what my graph means. In this case, we're talking about cost as my y-axis, in dollars, of course. And in my x-axis, if I look right here, I can see we're talking about number of tickets. And we're going to transfer that information on this side. So as you know me in class, I love to pick 0, 0, because as especially if my graph is increasing, I can see evenly if it's increasing from this point to this point without doing subtraction. And I'm going to pick the second point. I'm going to go up as my rise and over. That's my representation on my graph. So if I look from 0, 0 to 1, I rose. I'm going to transfer this answer here. I rose 1, and I went over. So from here to here, I went over 2. Okay? One more time, 0 to 1, I rose 1. From here to here, I rose 2. This is equal to my rate of change. Okay? Now if I look here at question A, it says, restate the rate of change as unit rate. Explain its meaning and show your work. So in this case, I already have my work shown with the graph, and I'm just going to transfer it here so that it is equal to my rate of change. So the 1/2 is equal to my rate of change. Now I need to find unit rate. And if we remember, unit rate is equal to 1. So that means if I look over here, I have my rate of change. Anything I divide by the same thing will equal 1. So I want to, in this case, divide by the denominator. So for here, when I divide 2 divided by 2, that is going to equal to, let me raise this up for you, 1 on my denominator. But we want to also remember that we're talking about cost in dollars is equal to number of tickets. So if the number of tickets is 1, we want to find out the cost. If it costs $1 for 2 tickets, well, I'm dividing $1 in half, or by 2. That's going to equal 50 cents. So in this case, it costs, and we can write our reasoning, it costs 50 cents for 1 ticket. In this case, we represented our rate of change, which is here, as 1/2. And we represented our unit rate. In this case, we can put equals unit rate. And this is our unit rate. And we explained our reasoning here. So we just did all of what A asked us. For B, it says, why do you think Shelley did not read the unit rate of change from a graph? Well, if we go back to the top right here, it says Shelley rates it as $1 over 2 tickets. Okay? If we go back to question B, the rate of change is equal to $1 of 2 tickets. So what Shelley actually read was the rate of change and not the unit rate. And many of us do that. We stop at the rate of change and we forget to do the unit rate. So in this case, we can put that the rate of change is equal to 1/2, or $1, so that's our cost, 2 tickets. Our cost to tickets. And our unit rate is equal to 50 cents for 1 ticket. Therefore, what did Shelley not think about? Okay? Shelley didn't think about unit rate. She just read the rate of change. What we see here is 1/2. So therefore, Shelley gave rate of change and not, okay, that's very important, not unit rate. So basically all we're doing is we're calculating the rise over the run using the graph, and we're writing the rate of change. We divided by the denominator to get the unit rate. So make sure you do that. This whole set of notes is what we did in class. This is our first one. That is your example. Now, as for the rest that is due tomorrow, let me go ahead and bring that up. 138 is pretty similar. There's only one slight difference. It doesn't give you this pre-selected points. So the main thing you want to do, and as you see here, I have pre-selected points with my green marker. is I want to look for points that are even on the line. If I see here, this one's even, which is 0, 0, my go-to. 2 and 1.5. I suggest not to use that because it is a decimal. 4 and 3. And 7.5 and 6. 0, 0, and 4 and 3 would probably be the 2 points going rise, overrun, to be easy to deal with. In addition, number 4 talks about cost of 10 items. If you have the unit rate, whatever the cost is to number of items, so if one item is $1, let's say, you would multiply it by 10. If it's $2, you'll multiply it by 10 to get the cost for 10 items. Now, the next thing I have is 139. I want to make sure you complete that. That should have been done in class, but if not, it's an additional problem for you to work on at home. So it's the same thing. It will ask what you prefer, the original rate of change to determine the graph or the unit rate to make calculations, meaning, as we did here in 138, how you calculated unit rate for 10 items. Last but not least, your homework. Your homework here is page 140, problem 4. You're going to determine the rate of change. You notice it doesn't say unit rate. It just says your rate of change. That's why I say always go back to the directions, because the directions might not ask you for as much as you'll assume. It's not asking for unit rate here. Letter C is going to ask you, these graphs look exactly the same, but how could they show different rates? So these are going to come out as different rates. To answer question C, I really want you to look at the Y and X axis. Are they the same numbers? Are they increasing by the same rate? So that should help you with homework on page 140. Thanks for tuning in for your homework help. I really hope this helps. Make sure that you save page 141 for Tuesday's Do Now. Have a great night.